Hello guys! Now that you know so much about hashes, let's move on and see what are the possible attacks on hash algorithms. There are three types of attacks on hash algorithms. A collision attack on a cryptographic hash tries to find two inputs producing the same hash value, hence the name hash collision. One of the properties of hash functions is that there is a unique hash for each input. So how could we have the same hash for more different inputs? Because a hash function can have an infinite number of inputs and a predefined output length, for example SHA-256 always produces a hash of 256 bits long, there is inevitably going to be the possibility of two different inputs that produce the same output hash. If two different inputs produce the same output hash, it is called a collision, which can then be exploited by any application that compares two hashes together, such as password hashes, file integrity checks, and so on. The odds of a collision are very low, especially for new and secure hash functions with very large output sizes. However, as available computational power increases, the ability to brute force hash collisions becomes more and more feasible. At this moment, in 2020, the SHA-2 family of hash algorithms are considered strong enough to be safe for the foreseeable future. If you are trying to perform a collision attack on SHA-256 or SHA-512 at a rate which is 1,000 times faster than the fastest computer in the world, you will need a longer time than the age of the universe. However, old and obsolete hash algorithms like MD5 or SHA-1 are not considered secure anymore because it's trivial to find collisions. I'll show you an example of a collision of MD5 and a collision of SHA-1. Let's take a look at these two images. You notice for sure that they are completely different. Let's calculate their hashes using MD5. They are on my desktop directory in another directory called hash collisions. I am moving to that directory. Okay, so MD5 sum, plain.jpg and ship.jpg, the images. And surprise! We notice that even though the input is different, the output hash is the same. This is a collision of MD5. If I used another algorithm, I would get different hashes. Let's calculate their hashes using SHA-1. It's different. This is a collision only for MD5. Now, let's see another collision, this time of the SHA-1 algorithm. There are these two PDF files that display different content, yet have the same SHA-1 digest. This is the first PDF, and this is the second. Okay, these are the PDFs. Let's see their hashes, SHA-1 sum and the PDF files. They have the same hash. By the way, to find these two colliding files was not an easy job. It was the Shattered project led by Google Research Security in 2017. You can find more information here at shattered.io. The attack required the equivalent processing power of 6,500 years of single CPU computations. The team has spent 2 years developing the technique and the cost of the resources involved was more than 130,000 US dollars at that time. Many collisions exist in all hash algorithms, but you cannot find any in a reasonable amount of time because it could take you years. I'll attach to this lecture the files that produce the collisions as a resource. Another attack on a hash algorithm is called first preimage attack, and it means to find a message that has a given hash value. If a simple collision means to find two messages that have the same hash, the first preimage attack means to find a message that has a given hash, and it's much harder to be performed but also more destructive. Imagine someone has the hash of a password and finds a completely new password, not the correct one, that has the same hash as the good one. And the last attack is called the second preimage attack. It means that for a given message, you should find another message that has the same hash. This is also very destructive. Just imagine you have a very important document that you want to send to someone, and the hacker creates a second document that has the same hash. The shattered attack we've just seen is just a collision, not a preimage attack. In general, a collision attack is easier to be performed than a preimage attack, as it is not restricted by any set value. Any two values can be used to collide.